Good morning, statisticians. We're going to talk about Chapter 8, Part 3 today, which is all about standardised scores. Okay, now standardised scores are for comparing test scores or things that are similar to that when we are comparing two people who have perhaps sat a different test or two people who are perhaps in a different class. Obviously, if these people were in the same class and had sat the same test, it would be fairly easy to see who has done better. You'd just find the person with the higher percentage. But let's use this example here to explain this. So we've got Freya, who sat a maths test, and Tom, who sat a stats test. Now, Freya's achieved 76%, Tom has achieved 84%. So it's very tempting just to say Tom's done better. But let's dig into this in a little bit more detail. We've got the mean scores for each, and you'll notice that the mean for the stats test is a bit higher. Okay, and then we've got standard deviations, which tell us the spread, tell us a bit of information about this, how spread out the results are. So the standard deviation for the maths test was 5%. The standard deviation for the stats test was 3%. Okay, let's plot these on normal distribution curves, and we'll see what's going on. So for Freya, her class had a mean of 62. And hopefully you remember a little bit about normal distributions. We're assuming this class is normally distributed, by the way, in terms of their scores. 5%, one standard deviation above and below the mean would take us to those numbers. And if these scores were normally distributed, that would contain 68% of the students. So 68% of the students should get between those scores. 2 standard deviations away, so 10% either side of 62 would take us to these numbers, and that would contain 95% of the class. 3 standard deviations, so 15 away from 62, would take us to 77 and 47, and that would contain almost all of the class, or 99.7%. If you remember, in the textbook it says 99.8, although literally everywhere else you look online and even with A-level maths it's 99.8, so I'm not sure whether that's just a typo. Anyway, let's plot Freya's score on there. So she got 76%, which we can see is almost 3 standard deviations away from the mean. So she's done very well relative to her class. Okay, so I say almost 3 standard deviations. Let's work out exactly how far away from the mean she is. So 76 minus 62, she is 14% above the mean. Now, if we work out how many standard deviations that is, all we need to do is divide by whatever the standard deviation is, so 5 in this case, and that tells us that she is 2.8 standard deviations above the mean. Now let's have a look at Tom. So let's plot the mean. So the mean for his class was 78. Standard deviation was lower. Okay, so 1 standard deviation either side would give us these numbers, 81 and 75. Now I've just used the same image here, okay, just to make this easier to see. But actually, if the standard deviation was lower, this would be a more squished in normal distribution curve. Okay, so if you imagine just squeezing it inwards so that these lines here were closer to the blue dashed line. Okay, that's what this would actually look like. But this will give us an idea. So again, 68% of his class achieved between those values. 2 standard deviations away, so 6% away, takes us to 84 and 72. And 95% of the class achieved between those values. And then 3 standard deviations are between 69 and 87. Now let's plot Tom's score on there. So Tom got 84%, which is right on one of our boundaries, and we know that is 6 above the mean. Okay, now how many standard deviations is that? Well, let's divide by the standard deviation, and that tells us that Tom's score was 2 standard deviations above the mean. So now looking at this, it's much easier to say who has done better. Okay, now we call these the standardised scores. So these numbers that we've got out at the end of this are called the standardised scores, and these enable us to compare 2 people in a different maths set, for example, or 2 people sitting a different test, or perhaps even a different subject. And from those standardised scores we can see that Freya has done better. Okay, we're talking about better in this context, meaning relative to the class. Okay, so you simply just look for who has the highest standardised score and we can say they have done better. Okay, so that's how we do it. Now you don't have to draw this diagram every time and do all of this. There is a formula and it just incorporates the things that we've done here. We took the score, we subtracted the mean, and then we divided that by the number of standard deviations. Okay, so unsurprisingly, that's what's in the formula. So the standardized score is the score minus the mean divided by the number of standard deviations. And that just tells us how many standard deviations above or below the mean their score was. Okay, we're just going to have a look at the worked example from the textbook, but there isn't really much more to it than this, so after this you should be able to have a go at all the questions. So again, we've got Freya. I didn't realise I'd used the same name, that's going to appear again. But we've got Freya and Vicky, who took an English test and a maths test. Both tests had a maximum mark of 100. Their results and statistics for each test are given in the table. So we've got their marks, we've got the mean for those, and we've got the standard deviations, okay, for English and maths. So we're going to work out their standardised scores first. Okay, so let's start with Freya. So in English, we just take her score. Oops, sorry, this one. Sorry, they're starting with Vicky here, apologies. Vicky, so they're taking 55, subtracting the mean, dividing by the number of standard deviations, and that tells us that her English score was 0.4167 above the mean. Okay, 0.4167 standard deviations, that is. Her maths score was bang on the mean. She got 42 and the mean was 42. So that's a standardised score of 0. That doesn't mean it's really bad. Okay, negative scores are bad. 0 is sort of bang on where you should be, and any positive scores mean you're above the mean. Now let's do the same for Freya. So Freya's standardised scores, take her values, subtract the mean. Okay, and you can see on this one, she's actually got less than the mean in English. Okay, so that gives us -4. When we divide by 12, that gives us -0.3 recurring. But we don't have to write recurring, we can just give it to a decent amount of decimal places. So she's not done very well in English, she's below the mean. And in maths, she is 0.375 above the mean. Okay. So, comment on the test performances. Who do you think did better overall? Sometimes this is tricky to determine, but it's one of those things that in stats, you know, as long as you've shown enough knowledge, you could probably give a variety of answers as long as your explanation is good enough to go with them. So, we can see that actually Vicky's done better in English, but Freya's done better in maths. However, Vicky's English score was a lot better than Freya's. Her maths score was worse, but not that much worse. Okay, so something along these lines would suit. I mean, this is the explanation from the textbook, so this is clearly the sort of thing they're after. So the lowest standardised score is -0.3333, obtained by Freya in English, and the best is 0.4167, which Vicky scored in English. Freya did better than Vicky in maths, as she got the higher standardised score. So we've sort of explained what's going on here, and then we're going to conclude by saying overall the best results appear to be Vicky's, since she did not get any negative standardised scores. Okay. Alright guys, thanks for watching, hope that helps. Now have a go at the questions please.